All right. Morning, everyone. Or not morning, it's like evening time. Back home now, so we can back to our old schedule. So, we got some graph problems to do. So, yeah, so let's see my progress of it. I've been doing a lot of league up and streaking a quite amount. Um, let's see how much problems I've been doing. Almost 500. My goal is to hit 500, and I think that's a good enough streak. Been doing it since September, but it's January now, so good streak. This is probably the peak of interviewing. So, but I do like at least one a day. That's kind of my goal, honestly, just one a day. And something on the list that is like something like NeetCode. I'm doing 250 because 150 I've basically done all of it except for DP. I need to go back to DP. Well, once I get there, I'll do it. DP is just really difficult. For DP, I will start all over, even though I've solved some of the problems. They're just really difficult to. It's just really difficult to wrap my brain around the intuition sometimes. But anyways, today we're still on graphs. So I've done all the course scheduler except for this one. This is a new one right here. So yeah, this is nice. I think I get the premise of it. It's some kind of like return true or false if you have a prerequisite to do it, you know. So there are total num courses you have to take, labeled from 0 to num courses minus 1. You're given an array prerequisites where prerequisite of I equals A of I, B of I. Indicates that you're given prerequisites where prerequisites equal A of I, indicates that they must take course of A of I if you want to take course of B of, yeah, A, okay, forever. For example, the pair 0, 1 indicates that you have to take course 0 before you can take 1, yeah. Prerequisites can be also indirect where A, B, B, C, then A to C, right? So that's obvious, okay? You're given an array queries where queries of J equals U of Vj. For the jth query, you can also answer whether the U, oh god, you're given queries U to V. For the jth query, you should answer whether course uj is a prerequisite of V or not. Oh, okay. I have an okay. Makes sense. Return a Boolean array where the answer jth is the answer to the jth query. Okay, makes sense. Makes sense. Oh, basically, okay. It's basically the same problem as course prerequisite. Why the hell is this function signature so fucking long? Num courses, num prerequisites, and yep. Okay, queries. Okay, so here, let's just understand the input here. So we have num courses. There's 2 courses, and they are the prerequisites is you have to take course 1 before you can take course 0. And the query is saying, can I take courses? Or what is it saying actually? You're given a queries where queries of J. So this is the 0 index. For the jth query, where you should answer whether U is a prerequisite. So is U a prerequisite of 1? No. Is 1 yes? But the twist is there's also could be indirects. That's why they mentioned this here. So for example, here we have no prerequisites. So false. There are no prerequisites and each course is independent. Come courses here. So now this is an indirect one. So they're both true. Now, is one a prerequisite of 0? And yes, that is true because we have a direct causal right here. Now, is 1 a prerequisite of 2? There's, yeah, that's another one. Okay, this is deceiving. I know for sure there's going to be like an example course where we have 0 to 1, where we go from 0 to 1, right? That's like in their prerequisites. And then we're saying, is this, and then 1 to 2, right? Right? And then the basically the query is asking, does 0 unlock. Is 0 a prerequisite of 2? 100%. This should be true, right? Yeah. I think that's relatively straightforward. Yeah, so this is another edge case to consider. Let me just actually see. No, I trust my instincts here. This is the reason why they added this here. So, okay, the idea is basically go through the queries and call a function. We'll call like a DFS type of situation. It's kind of like it's not really topological, well, kind of, but it's mainly DFS. And we just kind of go through the like route it takes us. So I do need to build a graph. So that's the easiest part, right? Build a graph. We use probably like a default dict. And then another idea is, okay, there are a total of num courses you have to take, labeled from 0 to num courses minus 1. You're given an array, prerequisites, or prerequisites of I equals A, B, yeah, okay. Build a graph. And then for every prereq, or for every query, call a function that answers the question, is U a prereq of V? So let's call it is U V, yeah. A prereq of V. Record Boolean, return list of answers. That's the general like idea of the code like boilerplate here. So for every query, call function that answers the questions. Now the answer of this call DFS. Let's do this. Also, we'll do DFS. So DFS, right? So DFS will DFS. So DFS, so DFS will help us solve this problem. Now, how do we implement DFS? So I think that this DFS does like a state situation. So I just want to go through every single child or neighbor that the current node we're on is. So we'll take these are the start and to the end, and basically get to the end. If you can get to the end, perfect. If you can't, return false. Simple. Yeah, it's really simple. Like so, but the problem is I do need to make sure I don't end up in a cycle. This is another cycle. So I need to make sure like when you go down the recursive path, I need to update the state you're in. So that I don't, cause any issues. So yeah, basically this DFS is basically starting from 1, going to 0, ending at 0. Can I get to 0? If you can, then that's true. If it's false, then yeah. So basically, okay, I'll have the start and target. Yeah. If target equals start, well, it's not really start, it's more like current. Right, current, right? If then return true. Return false. If it doesn't, right? That should be the base case, honestly. Or we're on a thing that we that is bad. So we'll also do like double. We'll have like an array of courses that we've seen. So lookup table, yeah, it's cur target, whatever. So pretty simple. So lookup table of like all the courses, which I'll have them as an array. So like course 0, false, 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 right? There's total of 2 courses, so like this, course 0, course 1. And then we just mark it as next thing, no, let's do values 1, it'll be 0, seen already, and then 2, completely seen. 3 values, because I've done this before. So 0, 1, 2, like that. Those are the 3 states. 2 being completely seen, 1 being I've been called on, but not done with. So that's the thing. So yeah. And yeah, basically this DFS will do that. So I think okay, we can start now. So build a graph, simple. This is a directed graph or undirected graph. It's in so one way. So I just need to do this. So we'll do graph here. Default dict. We'll do a list of them for every UV, I guess. I'll call it AB actually. AB in prerequisites. We will put graph of A goes to graph of B. Yep, simple. Then we're going to build a lookup table. Table we'll have here all zeros for now of num courses minus 1. So let me print this out real quick. I just want to see how many. So so prerequisite. Okay. No, I need to do this. Num courses. Yeah. The amount is always there, but the index will be there. Perfect. Yeah, that's yeah. There are 2 courses. I need to have 2 elements inside. So yeah. Okay, so simple. We have a table, a lookup table, and then basically the idea is like this. So for every query in not query called the for every query. So for every UV, and I also have a res here. Return res in queries. For every UV in queries, basically call DFS and like res the append the result of DFS starting from, so it's target, so we'll do the current, which is U and V. Yeah. And then return result. So now we have to implement the DFS function, so we'll do def DFS, which will be the current and target. And yeah, so I can need this above. That's fine. So the first state is if the current equals target, return true, right? Another state is if the current, so it'll be like this. So if the lookup or the table of cur is equal to 1, we also want to return false here, or we want to return false because I believe that would be a cycle. Another case is if table equals cur equals 2, I return false. Yeah. Otherwise, if the cur equals target, that's perfect. Otherwise, for every neighbor in graph of the cur, call the DFS on the neighbor and target. Yeah. And then if you don't find anything, it's probably just false. So now, if this is true, then return true as well. So that's kind of the idea here. So this prevents cycles, this prevents duplicate values, and this is a case where we do find a node, right? I don't know if this is necessary, but I'm gonna run it for now. Okay, that looks good. Too slow? Or I think maybe an infinite loop. Okay, Teely. Holy shit. Okay, I guess too slow. Okay. Wow. Yeah. Do I need this? Oh, wait, hold on. Actually, oh, hold on, I messed up. I never marked them, too. Hold on. A table, so... Wait, so table of neighbor... Oh, okay. First mark table of cur equals 1. Then this is 2. And yeah, that's perfect. That's all we need to do. I guess we do this. No, we're good. Okay, I actually made it worse. That was my intention of the... Hold on, let me see this. Print table. Maybe, hold on. Maybe I do... No, what am I doing? Mark this as... Oh, yeah, that makes sense, to be honest. Wait, what's happening right now? Which false is it returning? Wait, what, let me trace out what's happening. Oh my god, everybody's still 0. Oh shit, no. No, it's fine. Return false, if cur equals target, return true, if table cur equals 1, if for neighbor and neighbor cur, oh yeah. I messed something up, I don't know why. Hold on, I need to... Something is weird. I don't know what's happening. It seems like it never becomes 1. I'm missing something here. I don't know what's happening. Okay. Where am I going wrong? I feel like I'm missing a idea here. Wait, why the fuck does this work? No, I feel like it TLA'd because I have like an infinite loop or something. Oh my god, I need to reset the table. Oh my god, that makes sense, that makes sense, that makes sense. Hold on, let me reset the table. Yeah, let me reset the table. Yeah, so we reset the table so that happens. It works. Perfect. All right, see you guys tomorrow.